Hey there, Algebra 2 folks. How's it going? All right, this is lesson 1-2. It is a one-part lesson, unlike the last lesson. Took kind of 3 days, if you will, to cover it. This is 1-2, graphing linear equations, which means we're graphing lines. Linear means lines, straight lines, and that's all that's going on. Now, there's a few different things. The first 4 examples, I kind of want you to look, if I step back and you look at these 4 examples that are on the board, a number of things are in common. Number 1, all 4 equations start out as y equals. All 4 equations have a y and an x, or an x and a y together. And those are 2 really important things. If an equation has an x and a y, and it's a line, it's going to cross both the x and the y axis. If it doesn't have both x and y, we'll discuss that in a couple of examples. But you probably should have been exposed to this in Algebra 1, known as y equals mx plus b, where supposedly you were taught that the m part is the slope, and yes, that's a crazy letter to stand for slope, but yes, m does stand for slope, and b is where we hit the y-axis. Now there's a reason for that. That's an easy thing for me to talk about with you, and I hope you feel comfortable understanding it. If you look at this first equation, y equals 2x minus 5. If I label things the way you should have learned it, this is the mxb. So if you were told a year or 2 ago that the b was the y-intercept, now this is the y-axis, that's minus 5, also known as negative 5. 1, 2, 3, 4, 5. There's supposed to be a point right down there at negative 5 on the y-axis. Now I want you to think about this, because there's a good explanation for this. That is technically the point 0, 5. Like if you think of it as an ordered pair, this is the x-axis. You don't go left or right, so it's 0 from the origin, 0, negative 5. So I want you to think about that. What if my x is 0? What if you make that a 0 right there? 2 times 0 is 0. 0 minus 5 is negative 5, and you get y equals negative 5. In other words, if you make x 0, y comes negative 5, there's the point 0, negative 5. And that's why that number that sits there by itself, not attached to the x, is always the y-intercept. See, if I put a 0 right there, 4/5 times 0 is 0, plus 1 is 1. When x is 0, y equals 1, and so on. Okay, so that's the reason why we were taught that. All right, so let's deal with this. Now the slope is 2. And I know you've learned slope to be known as rise over run. Now we have an interesting scenario here. That number's 2. It's not in fraction form. It's not in rise over run form. And again, this is where it's weird talking to the camera and seeing a video, because I would normally ask you, well, that's 2. How do I make it a fraction? Where all you guys would kind of reply, put it over 1. So you guys, we think of that as 2 over 1. So from that y-intercept of negative 5, we're going to rise 2, run 1. So from this location right here, rise 2 spaces, run 1, put a dot. And you can kind of see, because of this 2, like every time this x went up by 1, the y equals would be double. Like if y was 1, it'd be 2 times 1, which is 2. If y is 2, it's 2 times 2, which is 4. Well, from 2 to 4 is 2. 2 times 3 is 6. 6 is 2 more. It's just telling you that the y gets 2 bigger every time the x gets 1 bigger. That's why we have this rise over run 2 over 1. Now, if we're drawing a straight line, I don't need more points. 2 points makes me a straight line, because I can put this ruler or yardstick or meter stick down and get it. I can certainly from here rise 2 and run 1 again, and I'll have 3 dots, but they'll all be in the same straight line. So there's that straight line. Hitting the y-axis at -5, rising 2, running 1, rising 2, running 1, rising 2, running 1 the whole time. That's the steepness of a line. For every 2 it changes this way, it only changes 1 this way, and that line goes up from left to right because the slope is a +2, so you're rising up, running right, rising up, running right. Now, next example is not a ton different, except that I put a fraction in the slope. And I know some of you see fractions, you're like, I don't like fractions. I get it. But fractions in this graphing actually are a little bit nice. They're in natural rise over run format. So here's my y equals m x plus b. My y-intercept is now 1, right there. So I'll put that right there. That's the point 0, 1. And this is telling me to rise 4, run 5 from here. So I need at least 4 more and a 5 run. So from here, we rise 4 spaces, run 5 spaces, and we're right about there. And we can draw that straight line. And there we go. You will see similarities and differences to the last line. Number 1, similarity. Both lines go upward from left to right, and that's because they both have a positive slope. One's got a +2 and one's got a +4/5. You'll notice this line is not as steep as that line. This one, the rise is bigger than the run, so it's going to be steeper. This time the rise is smaller than the run. We only rise 4, but then we run 5, so it's a flatter line. Smaller slope, smaller steepness. That's basically what's going on here. Okay, now we're changing up the game here a little bit, and we have to pay close attention to this portion of the video. We still have a y equals mx plus b situation. This is m, this is b. Instantly, my y-intercept is +4. So 1, 2, 3, 4. We have a dot right there. Okay, very specific part. You will see that this slope is negative. Please understand that the negative only applies to the rise number. You will always run to your right. Okay? So if it's a positive slope, you rise up, run right. If it's a negative slope, you drop. It's not technically a rise then. You drop, run right. I'm going to do this correctly and then explain, well, why, because some people always they drop 3 and go left 5. They drop and left instead of drop and right. Let me get this in here. 1, 2, 3, 4, 5. So from this location, because of the negative, I'm supposed to drop 3. 1, 2, 3. Run 5. 1, 2, 3, 4, 5. This is the proper way to graph this right now. Put your straight edge in there. And there's that straight line. And I want you to notice something that's important. This line goes down from left to right, and a negative slope should go down from left to right. See, folks, if you drop 3 and go left 5, thinking the negative goes to both of them, your line would have gone up from left to right, and that would be a positive slope. So that's very, very important. You always run right. Positive, you rise. Negative, you drop. Always run right. So again, this line is not very steep in terms of, say, the first line. Again, I don't care if they go in different directions, we can still talk steepness. This is only moving 3 this way, running 5 this way. So this number is even smaller compared to this number than this. So this line is the least steep of them all right now. This is the middle of the road steepness, and this is the steepest one so far. Okay, last one has one unique factor. You can see that this has a y equals mx, no b, technically. that is technically plus 0. You don't have to write that in there like that, but it's good to see it maybe the first time we run through this together and say, oh, so it's got a y-intercept of 0, which is code for the origin, right here. We are back to having a slope that's a whole number. So when we think rise over run, we need the over 1 concept. You don't have to write that every time, but it's just something nice to have there. So from here, we're going to rise 5, run 1. 1, 2, 3, 4, 5. Ready to run 1. So rise 5, run 1, right there. As we get ready to draw this line, people, this is the steepest line on the board thus far. Right there. Okay, folks, so there's an introduction to part of this lesson, in that a part of this lesson is going to be known as y equals mx plus b, or is often referred to as slope-intercept form, because you have the slope and the y-intercept. It should be called slope-y-intercept form. But there's the gist of that, okay? I'm going to pause a minute and get on to a different type of looking equation and a different way of graphing it. Okay, so now we're on to our next two examples, example 5 and 6. And you can notice right away these two equations look different from the first four. The first four all started out y equals. These do not start out that way. These have a very distinctive look to each other. This one, very specific. The x and the y are on the left side of the equal sign. A plain number is on the right. X and y on the left side of the equal sign, plain number on the right. Folks, that's called standard form. Not important, you know, when you think about it, it's just like, okay, cool name. But the way we graph them is a little bit different, and I'm going to show you the gist of it, and then show you a shortcut of it. But ultimately, here's what you're going to do. We're not going to talk about slope here. We're strictly going to talk about x-intercept and y-intercept, both of them. Now, let's talk about the y-intercept. See, if you're calculating where this crosses the y-axis, and I referred to that in the first four examples, anywhere up and down this y-axis, the x-coordinate is 0. It's 0 something. So like in those examples, like in example 1, it was 0, -5. In example 2, it was 0, up 1. In example 3, I didn't mention to this way, but the y-intercept was 4, so the point was 0, 4. And in the last example, there was no specific number there, so it was 0, 0. This time we have to physically do the work. If I want to know where it hits the y, so you notice I left the y empty, I force the x to be 0. And I'm going to plug that into that equation. So that would look like this, people. It would look like this. 5 times 0 in for x plus 3y equals 30. And see what's going to happen here, 5 times 0, see, made the x 0, that's 0. So I'm left with just 3y equals 30. An equation that I can solve because you and I learned that in previous lessons. So we just divide both sides by 3, and I get y equals 30 divided by 3, or 10. In other words, when x is equal to 0, y comes out 10. And I can plot that point, 0, 10. Way up there, okay? Now, we're going to reverse this process, people. We're going to now calculate the x-intercept and I haven't talked about this, but anywhere along the x-axis, these points are something 0. Like 1 to the right, 0 up and down. See, you don't go up and down to stay on the x-axis. So this time we're forcing the y to be 0. I need to find the x. So I'm going to take that same equation, but this time I'm going to leave the x in and make the y 0. So it's going to look like this. 5x plus 3 times 0 equals 30. This time, 3 times 0 is 0. I am left with 5x equals 30. An equation that I can solve for x. Divide both sides by 5. And I get x equals 30 divided by 5, or 6. In other words, when I make y equal to 0, x comes out 6. The point 6, 0. 1, 2, 3, 4, 5, 6. 0. See, x equals 6, no y 0, no up and down. Now, there's 2 points. I can grab my straight edge and make that line. It'd be right in that neighborhood right there, folks. When an equation is in standard form, we don't make a big note of the slope, like we don't actually know it. We could find it, but we don't know it right now, but we could definitely tell that this slope's negative because the line's going down from left to right, so this would be a negative slope. And the easiest way to just start calculating is you can go from this point, drop, run. It's drop 10, run 6, which can reduce. 10 over 6 can reduce to 5/3. So folks, that's a slope of negative 5/3 if I needed to know it for some reason, but just kind of throwing that out there. So I want you to notice something. As we go to the next example, I'm going to take this little mini shortcut. It's not a huge shortcut, it's just something to take the time away. I want you to notice, when I was calculating the y-intercept, and you got to be careful how you talk here, because you put a 0 in for x, so I can find y. Notice that the x disappeared from the problem and I just worked with y. Okay? So one of my teaching partners, Mr. Lent, he used to call this the cover-up method. I don't know if he still does or not, but when you're doing standard, if you notice this first part, if I just would have covered this up and solved that equation, 3y equals 30, it said it right there, and I get y equals 10. For the next part, if I cover up that part and just deal with what I have, 5x equals 30, that was right here, I get x equals 6. And that's because in one place, you're putting a 0 there, so eliminating that. In the next step, you're putting a 0 there and eliminating that. So I'm going to use that to my advantage over here on this next problem. 3x minus 7y equals 14. Now I've added 2 minor difficulties to this question. One, I've thrown in a minus sign, which implies the 7 is minus 7. And secondly, you're going to see that the x and y intercept don't work out to whole numbers, both of them, and that's okay. They don't always work out perfectly, and we'll do our best. So I want you to think about the y-intercept. That means you're putting a 0 in for x. Again, I'm going to take the slight shortcut. Folks, if I put a 0 in right there, that piece of the problem goes away. So I'm covering it up right now and just seeing what it says. See how that says? Negative 7y equals 14. Kind of a rough looking y there. Okay. So understand, if I put a 0 there, 3 times 0 is 0, that part's gone. If I just solve this for y, see that's the part that's missing, divide both sides by negative 7, I get y equals 14 divided by negative 7, or negative 2. So you guys, we have the point 0, negative 2. Right there. So that turned out okay. Whole number, just negative. Okay? Now, we're going to do the other one. So there's my y-intercept, documented and graphed and all that. My x-intercept. This time I put a 0 in for y because I'm finding the x. That's why I leave the x open. So you guys understand, if I put a 0 right there, 7 times 0, that part's gone. 3x equals 14. 3x equals 14. Divide both sides by 3. I get x equals 14 divided by 3. Now that's going to be 4 2/3. If you get a decimal, it'd be 4.6 repeating. You can either write it like that, 4.6 repeating, or if you round off to one decimal place, you can just call it 4.7. Because you're going to graph, it can only be so accurate. So if I go to 1, 2, 3, 4, 5, 4.6 repeating, almost 4.7 is more than halfway. So we're going to say about in that neighborhood right there. And there's 2 points, an x-intercept and a y-intercept to draw this line. And there it is. At the current moment, this one I don't know the slope as easy as I did the last one because this little decimal makes it harder to say, hey, rise, run, because it's rise 2, run 4 2/3. So that's a weird number. We'll talk about that later. It's not super important right now. I'm just kind of stating it. But there's the graph. So you kind of get that, how you cover up, solve for x, there's your x-intercept. Cover up, solve for y, there's your y-intercept, there's your 2 points. Done. Okay, so that's known as the standard method of graphing. Okay, I've got one other concept. I'm going to pause a minute. Okay, folks, last two. These are even quicker. Kind of it's gone quickly. I had the 4. They didn't go too slowly, and then I had 2 more, and those got through quickly. These are even quicker. Look at the 2 equations that are on the board this time. They have a distinctive thing about them. They're different than anything else we've seen. Number 7 has only a y. No x. That's an issue. Number 8 has only an x. No y. So you guys, here's what this means. If you have one variable only, you have to cross that axis at that location, but don't touch the other one. So number 7 means cross the y-axis at -5, don't hit the x. So here's the y-axis at -5. Okay? Think about this. Again, this is where I would much rather be conversing with you and talking with you and getting feedback. But if I'm supposed to hit the y-axis at -5, but the missing x means don't hit the x-axis. Well, how do I not hit the x-axis? Stay horizontal like that. See, if I'm horizontal, the x-axis is horizontal, I'll never cross it. So I won't use a ruler this time. See if I can draw a halfway straight line. So, a little wavy, but there it is. That's y equals -5, never crosses the x-axis. Now, something to note, you could back up the video and see, the other 6 examples all would hit the x and y axis. And I know you might look at the graph and say, well, yours didn't. It might be a case where I didn't have it drawn big enough for it, but every one of those was either diagonal this way or diagonal this way. It would hit the x and y. Even at example 4 hit it right at the origin. It's immediately hitting the x and y axis right there. So number 8, last one here, people. We need to hit the x-axis at 4. There's x equals 4 right there. And what, again, the message is, hit the x-axis at 4. The fact that y is missing from this problem don't hit the y-axis. Well, here's the y-axis, it's vertical. Your line must be vertical so as to run parallel. So that line is like roughly right here. So if you see an equation with only one letter, either x or y, it's either a vertical or horizontal line. Y only is horizontal, x only is vertical. If it has x and y, it's going to eventually hit both the x and the y axis. Okay, that wraps up that lesson, people. Hopefully that made some sense to you. Take care.